So I'll just share my screen here. Let's see. So really, oops, maybe I'll switch this. My slides are over here, so I'll be looking at them. So I'm going to move them here to a different screen. There we go. So I just wanted to share a couple things I picked up associated with Blackboard Pools with folks that were interested. Really, it's two things. One, I realized I could connect Blackboard Pools to suites of images that I created kind of programmatically to use in Blackboard assessments. And then the other thing, like I've struggled with Blackboard Pools, is I'm relatively new faculty. I don't have, or I haven't had the opportunity to get access to, many different test banks. And so I have just a limited number of questions for any one of my exams so far. And so, I realized that these types of like Blackboard tests, their students are talking with each other, at least some of them are. And so I wanted to make an attempt at making the test relatively unique, but not not, I guess, really trying to make Blackboard pools for non-math based questions that are relatively extensive, because I just, frankly didn't have time. So the first, I'll focus on, well, one, I'll just say that I learned about pools from folks here. Of course, I learned about them from John and Casey. I listened to them talk about it. And of course, Liz Schmidt as well. And of course, we all know that these pools are handy because they're sets of questions. They typically focus on a specific topic, and you can draw some number of questions from them in a random block on Blackboard. When I watched Casey do this maybe not this, I don't even remember, maybe it was last spring or last winter, I saw him make them in Excel. But and that's absolutely doable, but I'm a programmer in R, so which is something that allows professors in like bio and I don't know, maybe chem to use. Anyways, and so I just started creating pools using some programs in R, which was really great. But those pools were math-based types of questions where, there's some equation you can solve for whatever variable you want, and you can use the program to create, kind of realistic other things that go into that equation. And that's something I used in the fall, and I think that was helpful. I really liked it because it allowed me to allow what I let students take multiple attempts at doing something, like answering some of these questions about without getting into too much detail about some topics that we were covering in class. And there are new questions each time, so of course it's the same concept. They're trying to apply something that I talked about in some asynchronous lecture that was connected to this. And this is just some examples of some Blackboard pools where the math is, this is really just kind of probability theory, where you just count up how many A's, T's, G's, and C's are in this thing and this thing, and you can use some simple probability to calculate this thing called non-specific amplification, which is great for the students. But one other thing in this class, I should say this is a class kind of that's focused on genetics. It's focused on detecting species of interest, and you guys are all familiar with SARS-CoV-2 testing. It's the same kind of idea where you have some DNA, you're trying to detect some target species, and what I was teaching students in the fall was just kind of a lot of the background kind of information on how do you sample, where do you sample, how do the tests actually work, what's the theory that goes into this type of thing, and And so these Blackboard pools were helpful. But when I've done this in the past, I should say maybe another kind of background thing here is that um, because of room size restrictions in the fall, this class was the class I'm talking about, this Bio 492 was taught all online. So it was a different class than usual, but I wanted to use some of the stuff that I was creating for this class in future semesters. And with that in mind, in previous semesters, in the first 2 years that I taught this, when students actually get to interpreting some real data, they struggle with it. So really, I'm interested. The goal was to assess their ability in interpreting images using pools. And in genetics, one of the things that students need to do is be able to interpret these things called gels. And really, and these are two pictures of gels here, and really they're ways to look at the presence or absence of DNA fragments of interest. And I have of interest there because sometimes DNA fragments in the gels show up that aren't of interest, but really and I guess where they show up matters, and that's confusing for students. These things, they typically have some standards, some sets of known. So there's these positive and negative controls where there should be something, there shouldn't be something, and a set of standards, which are a set of known fragments of DNAs that are of a known size. And so like when you look at a gel like this, how you interpret them is that you have a lane, and DNA travels from the top of the gel down. DNA is this white band here, or these white bands. And then each lane represents a unique sample. And some of these samples are negative controls. So there's neg, neg, neg. So these things you should not see bands in, and we don't, and that's good. And then there are actual field samples where, these are samples that you collected in the field, and now you see some kind of fuzzy white bands in the gel. And whenever students make these gels, they're like, hey, they see, well, like for instance, down here, this is another gel. When they see these kind of faint white bands down here, they will incorrectly think that the gel worked, that they detected their species of interest, but they're not interpreting the gel correctly, because you need to look at your set of knowns, this DNA standard, or what often people call just a ladder. And then you also need to kind of compare any other lane in the gel relative to your positive control. So this is the target. This white band here represents where, if you saw a white band anywhere else in this gel at that spot, that would be a detection of your target organism. But of course, I shouldn't say anywhere else. If you saw it in any of your negative controls, that would be bad news for the assay. And so, but the general idea is that, when they do this, they typically only get like 1 or 2 chances to look at a real gel, maybe 3 in the time that we have during the semester, because there's a lot that kind of leads up to that. And so I wanted to create a situation in Blackboard where they could get practice at interpreting these gels. And so, because I had a little bit of familiarity with making Blackboard pools using this programming language called R, using these math-based questions, I realized, one of the other things that R is really good at is making a nice graphics. And so what I did is I created a program to make these things we call in silico gels. They're just, computer gels made on a computer. And so what I created was a suite of gel images where each gel image has some number of lanes. That's, these things here. You can kind of see the start of the lane up here. And then there are ladders in these in silico gels. So this is your known standards. And then this was just a really simple application where One of the first tests that students do when they are going through this in a typical year would be to run a positive control gel, where you found some assay in some paper on Google Scholar, and we bought the primers. We have some known template DNA, and basically it's just you're trying to replicate what's was already published based on what you found online. So it should be a really easy experiment. And so in this case, there's only two samples that they're looking at: a positive control and a negative control. NTC short for no template control. And with the expectation that you should see a white band somewhere in the positive control lane, but you should not see one in the no template control, because if you see something like that, then means that your reagents were contaminated. So ideally, you see something like this and not something like this. And an example pool question that I created associated with these images. Oh, and I should say another kind of important thing is that I created 50 gels, and so I labeled them gel 1, gel 2, gel 3, blah blah. And the structure of the questions identify where they should expect to see something in the gel, and what gel image should you be looking at. And then the multiple choice question associated with it had some kind of specific answers that could apply to any one question. That the positive control gel worked. If that was the case, you'd see something like this. The positive control gel did not work because the positive control didn't amplify. And so maybe I'll show you one. Can you see that PDF? Yes. So, some like here, this one would be like a gel that did not work. There is no ladder, there is no band in the positive control, there is nothing in the NTC. This is one that it could have worked, but it depends on, if I go back, the other kind of key piece of information is 219 base pairs. So if you look at the ladder is a set of DNA fragments of known size. So 100, 200, you should see a band, a bright band just above the 200 line. And so this might have worked, but it depends on the question. If the question gave some number that wasn't somewhere between 100 and 200, then that would be, it could be wrong. But the point is that using a program, you create a set of images that are referenced in the question, and that you have the students go to this PDF and answer one of these questions that are structured as a pool. And so, I mean, that's a relatively simple one. Things that I'm planning on doing for the fall is making more complex gels for them to interpret. And without getting into a ton of detail, I'll just say that these gels are there's more information in them, and you could use again, this is based on them watching some asynchronous lecture and talking about how to interpret gel images. They can look at the banding patterns here to answer questions like, what's the detection rate of your target organism, or what species is this? So I guess I'll stop there because I know I only have 5 more minutes. And the other thing that I did is, so that was in the fall, I used pools. And of course, in the spring, I wanted to use them as well because I was teaching this class, Bio 320. It was a synchronous online where they did have some they did have tests. They were relatively low stakes. They were only worth like 10% of their grade, but each. But the thing with the ecology class is that there wasn't a ton of math-based questions that I could use in any given test. And so, I realized that I could kind of use the and rule and probability, like, what is the probability of this roll of die, right? This is a 6-sided die. And so whatever the numbers are, what's the probability of rolling a 2 and a 4? It's 1/6 times 1/6, right? And so what I did is I used that idea to kind of make a bunch of random blocks in my Blackboard test, but for each random block, there might be only 2 or 3 questions, right? Then there's focus on a very specific topic that I wanted to assess them on. And of course, the answers are in a random order, but the questions themselves, they may or may not, the students may or may not have that question. And so, how unique are these types of tests? Well, it really depends on, the number of kind of sub questions you have for any topic. This is a spreadsheet table that I had for one of my exams where there's 25 questions. For question 1, there's only one type, it's worth 3 points, so the probability that the students all get it is 1. In question 2, there's 2 types, so the probability of any 2 students getting the same question is 1/2, and so on. So really it's the average of all these probabilities, which is 59%. And I ran a little simulation to look at the variation around that mean. And for the most part, most students had 50 to 70% of their tests was shared. So it's somewhat unique. It's not completely unique. So those were really my kind of 2 little things that I learned about, Blackboard pools and kind of meshing them with using like PDFs that have a bunch of images in them. Oh, I didn't realize I have a bunch of chats. We use R in economics too. And Casey has his hand up.
Yeah. The idea of using a programming language, didn't really come to mind to me 5 years ago, 6 years ago, completely. And it was just because I'd been using Excel to kind of figure out questions in Angel anyway, as a check. But as I put in the chat, I know Ann Carley has used Perl and C++ to kind of generate sets of questions as well. One of the things you're using random blocks as opposed to a question set in your test. Is there a reason?
I don't know. I mean, the question set is like, so if you had a set of questions, I mean, maybe it's wrong. I'm not sure.
No, I don't think it's wrong. I think it just comes down to, and it took me a while to wrap my head around the difference between a question set and a random block in Blackboard. The question set uses all of the questions in the pool you select. The random block allows you to select a subset of questions in the pool.
Oh, go ahead.
I was going to say, so if every one of your pools is basically the same question with just the randomness built in, if you create your pools so that every pool is a unique question with just the randomness built into it, the question set's really easy because you just have to pick that pool and it picks 1 or 2, whatever you tell it, out of that entire pool. You don't have to select questions within the pool. If you've built pools that have different types of questions within them, then you do want to use random block because you have to pick and choose the set of questions you want. And so what I've really converted to doing is every question type I create is its own pool. So then I can just do question set and it'll pick one of however many out of that set.
So will that question then be the same for all students, or it'll be?
It randomly, so a question set randomly chooses 1, 2, 3, however many you tell it,
you want.
out of the pool. So if you have a pool of 600 questions, all you have to do is click that you want it to pull from that pool, and it'll do all the questions. as opposed to random block where you could pick and choose within the pool which questions you want to deploy.
And yeah, I guess I should be using sets then, because I know, like when I do a random block, it says, well, which questions do you want? And you can draw from true, false, multiple choice, or the bajillion other question types that they have. And I always thought that was kind of funny. So I guess I'm using it a little wrong. Well, I mean, it's built, random blocks seem to be built for more complex draws from different types of questions.
Right, and or you have different types of questions within a given pool, and you only want question type A, not B's, to be delivered to the students. And that's, like I say, why I ended up doing all my pools as just a pool for each question type.
Each question type.
And when I say question type, it's not multiple choice true. It's just this question with all the randomness possibilities. That's a pool.
Right. Yeah.
The other thing I was going to bring up, and I started doing this a little bit over the last couple of years, is you can load your images into Blackboard.
Right.
And then you can use HTML to call those images. So you could pull that gel image or the two gel images straight into the question with HTML coding by using the reference URL to the image once it's uploaded. I'd
love to try that out, and maybe if I can find a way to try it out in a low stakes environment. But my experience with images so far has been, when I've loaded it directly into the question, I always get students email me, I can't see the image. And I don't know if they're lying to me or not, but the first year, spring 2020, I just had to drop the question because I would get, I don't know, a third of the class that would say, some question image wasn't, they couldn't see it. And so in what I've done, or what I did in the spring 2021 here, is I would put the image in there, but I also had a PDF that would show up in the folder at the same day, at the same time as the exam, so that even if you couldn't see the image, right, you now have the PDF, which I know you can see because you look at all the PowerPoint slides, hopefully, for the class.
Right, and I would agree that that's a really good backup. And I know some folks over the last year and a half had some hiccups with images in tests. And I think Kathy Dutton and others have kind of figured out some of what those causes were.
Yeah. So if I could understand it, maybe, that's it. I just need to use HTML code, like you're saying, and link it to some URL where the image is.
But I just wanted to make you aware that that's also a possibility. But I agree, having the giant PDF of all 50 gels or all 50 possible images is a good backup. I might have to go play with R.
I'm around. I always like talking about it.
Okay. Thank you. I'll stop the recording and then we'll shut down and we'll reopen in just a minute.